Hey there, this is MathCamp231 presenting a lesson on Chapter 3.1 in Geometry, Congruent Figures. I'm going to go over a few definitions and write some things down, and I'd like you to write the same things down in your packet as well as I go through this. So feel free to stop the video as needed to catch up and then resume when you're done. The first definition that we're going to talk about is that for congruent figures. Congruent figures are two figures that have the same size and the same shape. And I've given you an example of two congruent figures down below, identified as Roman numeral 1 and Roman numeral 2. Now if we just look at these, they appear to have the same size and they appear to have the same shape. And one thing that I like to do if I'm assessing if two figures are congruent is I like to imagine cutting out one of the shapes and seeing if it would fit directly on top of the other if I placed one on top of the other. So if we read the little note down below the figures, it says, if you cut both figures out and placed one atop the other, all the parts would line up. We call these lined up parts the corresponding parts. And that phrase, corresponding parts, is something that comes up again and again in this chapter. So make sure you understand corresponding parts, or the parts that line up. The first question asks, which segment in figure 2 above corresponds with segment DE? Well, if I look at segment DE, which is up here, I'm trying to find the segment in figure 2 which corresponds or lines up with that segment. And if you said segment LM, you'd be correct. Okay, question number 2 asks, which angle in figure 1 corresponds or lines up with angle O? Let's find angle O in figure 2. Okay, so angle O is in that little bottom corner over there, and if we were to cut that image out and place it atop image 1 or figure 1, it would line up with which angle? If you said angle G, you're correct. So if two figures are congruent, they have the same size and they have the same shape, and if you cut one of the figures out and place it on top of the other such that all of the parts would line up, those parts would be called corresponding parts. Okay, the next definition that we come upon is that for congruent triangles. Two triangles are congruent if their 6 pairs of corresponding parts are congruent. And when I refer to the 6 pair of corresponding parts, I'm referring to the 3 angles that make up a triangle and the 3 sides. If we take that definition and we write it as a conditional in if-then form, we might say something like this. If two triangles are congruent, then their 6 pairs of corresponding parts are also congruent. If we formulate the converse of that statement and switch the P and Q around, we would say, if the 6 pairs of corresponding parts of two triangles are congruent, then the two triangles are congruent. Okay, number 3. Given that triangle ABC is congruent to triangle DEF, what 6 conclusions could you draw? Well, according to the definition of congruent triangles, if we have two triangles that are congruent, then we have 6 pairs of corresponding parts that are also congruent. And those are 3 pairs of angles and 3 pairs of sides. So let's identify the congruent angles first. Let's start with angle A. Angle A must be congruent to angle D. And I'm going to go ahead and mark that in the diagram. The next set of angles that I feel would line up are angles B and E. So I'm going to state that angle B and E are congruent. And I'm going to mark them accordingly in the diagram with tick marks. The third set of angles that would line up are angles C and F. So I'm going to say that angle C is congruent to angle F. And I'm going to make the appropriate markings in the diagram. Now let's move to the sides. Segment AB, which is the left side of the triangle, would correspond with the left side of the other triangle. So I'm going to say that segment AB is congruent to segment DE. And I'll go ahead and make those markings in the diagram to indicate that congruence. The next set of sides that would line up would be sides BC and EF. So I'm going to say that segment BC is congruent to segment EF. And I'm going to mark those accordingly with tick marks. The final pair of sides that would line up would represent the bottom of the triangles. Those would be segments AC and segment DF. So I'm going to say that segment AC is congruent to segment DF. And I'll make the appropriate markings in the diagram to conclude. So once again, in summary, if two triangles are congruent, then you could go on to say 6 things. You could list the 3 sets of angles that would be congruent, and you could list the 3 sets of sides that would be congruent.